नमस्कार दोस्तों। आज की वीडियो में हम जो है कर्व नंबर के ऊपर बात करेंगे। बात क्या करेंगे कि हमने देखा लाइक दिस इज आवर 2D mesh and rain on grid analysis. If you are going to do so, it means you are going to give rainfall to each grid, each cell, and that cell have to calculate how much runoff will takes place from that cell. So for that you have to understand about the curve number, about the infiltration, about the losses. So all these things you have to understand. So for that there is two method, there is two way to give that infiltration map to this layer, to this model. So for that first of all I'm going to tell you how you can calculate, how you can create this curve number layer, and you have to import that curve number here, and each grid, each cell will get a particular curve number on the basis of soil, on the basis of LVLC, uh, on the basis of AMC. uh, you have to give a curve number, and after that the model will easily understand the runoff on the basis of rainfall, and it will also give you the inundation map for the rainfall. Okay, so first method is using ArcMap, ArcGIS. So here you have to, like this is my soil. I have given here soil, like in my, this is FAO soil. Here only one class is lying in my study area, and for each type of soil there is a hydrological soil group. All soil have been categorized into four categories, like hydrological soil group A, B, C, D. Like you can understand, like a particular type of soil have a different infiltration process, different infiltration capacity, infiltration procedure. So on that basis, on that like sandy soil have more infiltration capacity compared to the clay soil. So on that basis there is four categorization of the soil, that is called hydrological soil group, and you will find it from textbook and research papers. And if you are a SWOT user, then you can understand in the SWOT database you will find for a particular soil there will be a HSG hydrological soil group. So for that soil, this soil which is lying in my study area have D HSG. Okay, and in my study area, as I have taken Israel LLC, and in Israel LLC this is I have converted in polygons. So here you can see that these classes lies in my study area, built up around rangeland, forest, and water. So this is LLC of my study area, and after taking intersect of these both, intersect I have taken intersect of these, I got this layer. You can say that you can say it curve number layer. Here you will find LLC class and HSG as well, and on these basis you can generate this curve number, and you will find like if LLC is this type and HSG is this type, then what curve number will be there. So I have created this. How you can create? You just copy this, and after copying this, you can paste. After copying this, you can paste it here, paste it in like Excel. I pasted it in Excel. Here you can see I pasted it in Excel, and for this class and this HSG the curve number is this much. Similarly for all class I have arranged it for first barren, second built up, then forest, and rangeland. So similarly you have to just copy it and you have to paste in this attribute, and you will create one curve number layer here, and this is your curve number sheet. And after that you have to go in your HEC-RAS in map layer. You have to just click here, create a new RAS layer, and you have to click here HSCSCN curve number, and you have to just click here and go into your folder where you have saved this curve number, and here you have to just click on that and open that. And if you want to select that curve number, you have to just, here curve number is not visible, it means there is a problem. uh, Here I didn't save it, I think so. Save it first. Okay, as I saved it, and now you have to go here and first delete it, and again you have to select that curve number, and let's open it. And now you can scroll here. Again you are not finding that, so let's see what is happening in the ArcMap. Here in the curve number, you have to open your attribute. You will find the curve number here. Okay, you will find this curve number here, and after that you have to close it. You have to remove it, and again let's see here, here, here. Let's select, open it, select it. Now let's see, our number is here, I think. Where is our number? Not finding the curve number. Yeah, add it. Okay, so I got that curve number, and after that you have to just click on create, and the things will be created for you. After that you have to just click on this, and when you go on this layer you have to click, right click here and click on here. You will find, these are your classes, and these are the curve number. On the basis of everything, the curve number is here. Now the abstraction ratio, minimum infiltration loss. Okay, let's make it 0 no data. By default it is created. Now for each class and for the curve number, there will be minimum infiltration ratio. The minimum infiltration ratio is 0.2 times of S. S is the retention, S is the loss. So zero point 0.2 times of the loss. And what is S? S is nothing. S is S equal to 25400 upon Cn minus 254. So here let's open the calculator. Let's open the calculator. 25400 upon 96 minus 25 is equal to 10. This will be in this is in percentage, I think. So you can write here minimum filtration ratio is 0. This will be in meters. We will write as 0.01. Not here. Here you can write 0.01. Similarly for this, minus 25400 91 minus 25, this will be 0.1. 25, this will be in mm, and next one is 25400 upon 81 minus 2 5 0.5. Here vegetation 89 for 89 2 5 4 double 0 89 minus 2 5 5 for 0.31. You have to check once this is that equation is giving s in meter or in centimeter, then you can do this. So I'm just giving it in it's, if you give it in centimeters, I am giving it in like in meter, then I have like in 1 meter is equal to 100 centimeter, 1 centimeter 10 mm. So I'm giving it if it is in meter, I'm just divided it by 100, making it okay, let me divide it by 1000. Suppose it is giving in meter, so I'm giving it in mm. Okay, so make it 10 mm. Minimum filtration rate. This is not infiltration rate. Okay, let me check how to calculate infiltration rate. How to calculate minimum infiltration rate. Minimum infiltration rate is there any many equation? Yeah, empirical. Like I have what I have here abstraction ratio. I have 0.2, 0.2, 0.2, 0.2, 0.2, 2. Like I have curve number, then how can calculate abstraction ratio and can calculate abstraction ratio and minimum infiltration rate. Here you will get maximum potential retention 25400 constant minus this. Okay, in empirical in inches in mm. This will give you in mm. Okay, this will give you in mm. There we are doing here it dictates abstraction ratio is 0.2, like 20%, 0.2. Okay, abstraction ratio is 20%, 0.2. So here you can give abstraction ratio 0.2 everywhere, and minimum Okay, determine minimum infiltration ratio. So minimum infiltration ratio is governed by this. Example, if you have water set have curve number 75, okay, then you will get S is this much, and initial is this much. Okay, this means it, this much of rainfall will be completely absorbed before the surface runoff begin. So identify the minimum infiltration ratio. So look at your original soil mapping data for generated curve number 75. If the design table shows that the layout corresponding the HSGB, a minimum steady FC settled between 6.8 to 7% during the storm event. So on this basis, if HSG like my HSG is D, okay, and the minimum filtration should be less than 1.3, okay. So let's take a value, a random value. Okay, here I'm going to give 0 0.3, 0 0.5, 0 0.2, 0 0.3, 0 0.4, 0 0.8, here 0.01, 0.6. Okay, so randomly I'm giving this one, and you have to just close. Okay, so similarly, you will get this infiltration uh, ratio infiltration from ArcMap you have to create, and you have to make it here, and you can assign the things, and you will do the process. And second way is like you have to first you have to first add a land cover layer here. Okay, land cover layer here. So I have current LLC. I have this LLC, and I have to make it here properly. And when I added this, you will find LLC here, and in that LLC you will find this class. You can give the manings, percentage impervious. Okay, and it will useful. And after that, you have to add a soil layer as well. So I'm going to add my soil as well, and here this is the soil. I have to add this, and I have added this soil here, and now you can create this infiltration layer from uh, that soil and everything you have given to the model. So here you have to select your land cover, you have to select your soil. It will do the same thing, and let me click here, and YouTube already have exist. Okay, so I'm going to no, I'm going to give it a different name. Okay, now it is created here something. You have to just go here. You will find the things like this is our soil. Okay, here you can, this is soil, this is LLC. So on this basis you have to assign the curve number here and here. Okay, and similarly you have to give abstraction and manix. So you don't do much things in your ArcMap and other platforms. You have to do that here, and after that you have to assign everything to the geometry, and you have to run the model. So that's it from my side, and thank you. We will see you in next.